Hello students, and welcome to another video. Today we're going to be discussing percent yield when it comes to stoichiometry. We're going to use this equation here, but before I jump into this, let's use this example down below. So right here we have hockey players playing hockey, and on the left side here we've got a chart that shows how many this hockey player, okay, this forward here, missed versus how many they made. So this person shot 30 times but only made it 2 times. Okay, so about 7% of the time they're going to shoot a score. So they've got to basically shoot for the goal quite a few times before they start having some points scored. Okay, and this is a good representation of what happens in chemical reactions, because a lot of times we calculate out what we're going to create, and then when we actually do the experiment we get way less. And a lot of the times is because of just the nature of doing chemistry. There's things that get involved that you don't intend to in your experiments, or stuff sticks to the glass, or your masses were recorded wrong, and you've got to, it's just never a perfect situation every time. If this person was perfect, they would have scored all 30 goals. But that's not true, right? This defensive goalie represents the difficulties of chemistry and reality that not everything is going to go as smoothly as you want it to. So in this case, this person shooting the goal doesn't make very many, okay? Because reality's there, okay? Just like chemistry, we want to make 100% of our reactant, and there's not a lot that's made, okay? Now, to calculate this, they have the actual score divided by the theoretical score. So the theoretical score in this game would be 30 times, because that's the maximum amount of scores that could have been made. But actually, there's only 2. So 2 divided by 30, and then we make it a percent, and it's about 7%, okay? The concept's there. I think you understand what's going on. I'll apply it to chemistry. Here is 3 definitions. You need to know these definitions. Please write them down in your notes. So pause the video, write them out, and also write down this equation too, okay? Because we're going to write these things out. So the theoretical yield is the maximum amount of the calculated value of reactants forming products, okay? This is going to be the maximum amount of product that can be formed, okay? The actual yield is the amount of product made during a real reaction. So this is, the actual yield is what really happened, okay? This is what you want to happen, but reality sets in and we usually will never get to that full theoretical yield just because there's difficulties with working in a lab. There's lots of variables to control, okay? And the percentage yield is the ratio of the actual compared to the theoretical yield, okay? And that's represented in this equation, okay? So become familiar with this. It's also, I believe, on the back of your periodic table. Let me grab it. Yeah, it's also written here as percent error. It's the observed value. That's a little bit different. Never mind. I don't have it written on there. So it's just one of those things you're going to have to write down and know. Okay? All right. All right, let's do this. So down here, we have a theoretical yield. We have 2 molecules of nitrogen, we have 3 moles of hydrogen, and we could make 4 molecules of ammonia, right? But when we did our reaction, there was some oxygen gas that was mixed with our hydrogen, so it actually caused some of our hydrogen to form water molecules. So it didn't make a perfect yield. What we do is have 2 nitrogen molecules, we have 6 hydrogens, but we only end up making 50%. We only have 2 ammonias, and we have some leftover excess reactants. And up here we formed water instead of our ammonia product because of this side reaction that occurred, okay, because there was some contamination. So if you were to calculate this, you would say, well, I only made 2 out of my theoretical 4, it would be 50%. Okay, now let's do a problem together in the next video, going through and actually solving one of these theoretical yield problems. Okay, thanks for watching.